Hi, this is Glenn Martin. You're watching Learning vSphere 6 from Pact Publishing. This is video 1.1, Course Overview and Virtualization Concepts. I'm an infrastructure manageability and security architect based out of Ottawa, Canada, but I also have been working for the last 20 plus years as a technical trainer and course developer. So I've done a lot of work with vSphere since about version 3.5. So this initial video is just going to serve as a general overview of what we're going to see throughout the course, but we'll talk a little bit about what virtualization is and why it's interesting to us. We'll talk about the role that VMware vSphere plays in that, and we'll also talk about some of the major features of vSphere, which is really going to give us, I think, a lot of the structure for what we're going to be talking about. So virtualization is all about running multiple virtual machines on a single host, well, potentially multiple hosts, but at least taking one physical server and running a whole bunch of virtual machines on it. Each of those virtual machines having their own operating system installation image, their own configuration, and their own applications running inside of them. This is basically a complete virtualization of all of the hardware that would represent a standard x86, x64 type server. There's a virtual BIOS, there's some level of virtualization of the CPU, there's a virtual chipset, there's virtual SCSI and IDE storage controllers, virtual network interfaces, virtual USB interfaces, actually even virtual PS2 interfaces for guest operating systems that might require that. So this is virtualization as opposed to emulation. So you can't take an operating system that was designed for something other than Intel AMD type x86, x64 instruction set systems. Some things are more virtualized than others, and some things are virtualized in more than one way in order to provide support for different operating systems of different vintages. So by virtualizing, really what we're trying to do is take those physical servers that we have in our data center and ensure that we're getting the most utilization out of them that we can, and also recognizing that over time they're going to fail or need to be replaced before they fail. So virtualization gives us a pretty easy way to do that by reducing the dependency of the guest operating systems from the hardware themselves by providing not only a standardized virtualized environment, but again, something that might be tailored in various ways to what that guest operating system expects. And this pretty much comes down to the type of network card that it's going to present or the type of SCSI adapter that it will present. I think you'll see how it also facilitates the deployment of that workload, makes it easier to deploy, and also makes it easier to manage over time and either add or remove resources as necessary. And this will generally let us not only make the most out of our capital investment that we've made in acquiring our hardware, but also the operational expenses by not requiring us to have, one server with one operating system with one application installed on it. We're going to save quite a lot in terms of space, power, weight, cooling, cabling, and the amount of time that we spend managing all of that in the data center. Virtualization not only gives us the option to optimize some of the spending that we're doing in those areas, but also introduces a lot of new capabilities and a lot of new concepts and a lot of new agile and dynamic features that we didn't have in an environment where we'd be tied to vendor hardware lifecycle releases and then also trying to manage our software lifecycle releases on top of that. And unfortunately, software has a much longer lifecycle time than hardware does. But of course, sometimes we end up having to run software much longer than the hardware that it was designed to run on, and virtualization helps us bridge that legacy gap as well. There's a lot of things that you get through the combination of the ESXi hypervisor operating system, which we'll talk about, and the vCenter management server, which we'll also talk about, and then various other add-on products that can be enabled past that. So there's a lot of features of vSphere that are integrated into it. We'll talk more about those as we go through the next few slides and throughout this course. But with other products like VMware View Horizon, we can provide a virtual desktop infrastructure capability with a lot of workflow type tools for deploying large numbers of virtual machines that might have relatively short lifetimes compared to a server. We can also do virtual SAN, where we can take our local storage and make that effectively look like a shared storage environment that we can use for features like HA and vMotion and so on. So as we add deeper and deeper integration between our servers and our hypervisors running on those servers and the storage and network that we have in our environments, we get closer and closer to something that marketers have been referring to recently, or at least, beyond the cloud, which is also certainly the most recent popular term, looking more at something called software-defined networking in data center. And people talk about the public cloud versus the private cloud. When you think of something that basically just works and you put your credit card in and it gives you a gumball or something like that, or gives you a huge amount of scalable storage for your application or whatever it happens to be, I think we can reasonably call that the cloud. But when you're talking about it in your own environment, you're much more interested probably not in the service aspects of it, but potentially the ability to very quickly dynamically adapt your environment based on changes. And that's really where something like private cloud kind of blurs the two concepts, whereas software-defined networking and software-defined data centers gives us a much better understanding about how this is really about integration with concepts like DevOps and the idea of things like infrastructure as code. And that gives us some very interesting capabilities when you start really wanting to scale quickly. Yes, we can scale vSphere actually quite quickly with things like vMotion and the distributed resource scheduler and so on. But how well can your application respond to scale? And then once you start doing things and having to coordinate how we scale our hypervisor environment with how we scale our application environment, the more we can integrate that, the better, and the more efficient and the more agile we'll be. Depending on how familiar you are with virtualization, you may or may not be aware of some of the features that it really does give us. Beyond the idea that we can just run virtual machines on the same hardware, one of the absolute blockbuster features of vSphere is something called vMotion, where we can take a running virtual machine and send it to another host, or take its storage and send that to other storage while it's running. This opens up some tremendous new capabilities for doing things like replacing failing hardware in a proactive way and upgrading hardware as necessary without having to take the affected workloads offline. So very, very interesting capabilities. And once we have this vMotion capability in place, it opens up some tremendous new options for us in terms of being able to dynamically shift our workload across the host in an automated way using the distributed resource scheduler. In addition, as we put all of our various virtual machines onto these hosts, then the nature of the risk associated with having one host fails on us goes from the potential to taking down one application to now potentially taking down many applications. So high availability gives us the ability to restart a virtual machine on another host if the host that it was running on fails. Or maybe its networking fails, or its storage fails, or maybe something inside that virtual machine has failed. High availability can, in various scenarios, detect that and get that virtual machine restarted. But that does incur downtime. Potentially that virtual machine is just one of many operating in some kind of load balanced fashion, and maybe we won't notice that that particular virtual machine is no longer doing whatever it was supposed to do, but that virtual machine has failed in some way and we need to recover that. In comparison, fault tolerance takes the same virtual machine and runs it in two different places at the same time. So it stores the virtual machine once, but actually keeps all of its operations in lockstep across two different hosts at the same time. And in the event that one of those hosts fails, then the virtual machine can transparently restart its secondary somewhere else and just keep going without any failure at all. So this is much different, although there's some serious performance considerations that we're going to need to take into account before you can actually do this. And some serious limitations too. So once we have vMotion and we have the ability to manually migrate workload, manually migrate virtual machines between our hosts and our storage, that's great, and we could do it manually, and we could certainly, if we were doing a lot of capacity management, we can now manually adapt our placement of our workload to meet our capacity needs. But of course, if our capacity needs change over time, it's going to be more and more difficult to constantly shift all of this for us, right? So if you're licensed for VMware Enterprise Edition, you can use something called the Distributed Resource Scheduler, which tracks the performance statistics associated with virtual machines, and then based on how well the load is balanced across the hosts in the cluster, we can actually move those virtual machines using vMotion in an automated way. We can specify how aggressive we want to be for that, and we can also configure various rules for how that should or should not happen in order to make sure that we're still meeting our other availability requirements for services that do depend on multiple virtual machines. And tied into the Distributed Resource Scheduler is something called Distributed Power Management. So with the Distributed Resource Scheduler, I can make sure that I have the best placement of my virtual machines across all of my hosts. But if I have more hosts available, if I have more capacity available than I'm really using, it's good to distribute my workload, but do I really want to be paying for power usage for those servers when I don't need them to be? Do I really need to be using cooling capacity for those servers when I don't need to be? So that's really what we're going to look at throughout this course. We're going to take a look at ESXi, installing it, managing it, the initial configuration of it, and that gives us a lot of the basis for everything else that we're going to do later on. So once we have ESXi installed and configured, then we'll take a look at creating and managing and monitoring virtual machines. We'll also take a look at integration with our networking and our storage, and that's something that can go quite easily if you wanted to, but can also become quite complicated if necessary. If you're running in a very large and very segmented environment, our networking could be really quite complex, and our storage needs might also be quite complex as well. So we'll take a look at a lot of those potential issues and some of the approaches we can use with them, We'll also talk about how to make sure your storage is working most effectively. At that point, we'll really have a very good idea of what it takes to get ESXi up and running on one machine, and of course that's going to give us the model for doing it across many machines. But as I start having all of these ESXi hosts, I'm going to want to manage them in a more effective way, and that's where vCenter comes in. So we'll take a look at installing and configuring vCenter and everything that goes along with that. And we'll also take a look at some of the capabilities that vCenter gives us. But most importantly, when we have multiple hosts and then we've also got vCenter, then if we can develop some kind of shared storage solution, that can give us a very, very good platform for running other features that we've been talking about, like vMotion. Take a look at that in section 6. And then in section 7, we'll also take a look at alarms, and we'll talk about performance monitoring with the performance charts and the ESX top utility. And we'll also take a little bit of a look at some of the other useful ESXi tools you might need in a troubleshooting and monitoring type scenario. So that's really what we're going to be doing as we go through the course, and that'll kick things off.